All right. So I'm going to go over the first two here, 1A and B. So my first order of business is, right, I need to find a square root, and it's the way we've learned how to do it. So I need to break 441 down into its prime factors, right? So you do the factor tree, you check 4, 4, and it's not even, right? So we're going to try 3. If 3 works, 4, 4, and 1 is 9. So 3 works, right? 3 goes into 4 one time. There's 1 left over, so you have 14 left. 3 goes into 14 4 times. You have 2 left. That makes this 21. 3 goes into 21 7 times, right? So it's 3 times 7. It's still odd. We're going to check 7 and 4 is 11 and 1 is 12, right? So 3 still works. 3 goes into 14 4 times. There's 2 left over, so that makes it 27. 3 goes into 27 9 times. And then you break it down to 7 and 7. Okay. Therefore, right, the square root of 441 is going to be the same thing as the square root of 3 squared. And the key here is to make groups of 2, right? You want to pair them up. Got 2 there, 2 there, which will allow you to cancel the powers with that square root. So some teachers won't like this, but I don't mind doing that, right? All these powers, as many as there are, will all cancel out with that square root. So you end up with 3 times 7, which is 21. Okay, if you did your homework, you probably recognize that. But I didn't really, it was optional, so I remember that. But this was in there under that, okay? And then the next one is cube root, so I need to make groups of 3, right? That's the key here. So I'm first of all gonna break down, I'm gonna do the work here, right? You check. So this one is gonna be a little bit more challenging. 3 and 3, that's 6, 2 is 8. So 3 doesn't go into it, right? So you try going up the ladder, right? The prime factors are 2, 3, 5, 7, 11, 13, and the list goes on. So if you remember the first couple, usually they do the trick. So this doesn't work. 3 doesn't work. 5 definitely doesn't work. Then you try 7, right? 7 goes in here once. Then there's 6 left over. That'd be 63. Goes in there 9 times exactly. Then there's 1 left over. So 7 doesn't work either. Try 11. Right? 11 goes into 13 once. I'm actually going to try that. Right? Pretty confident that'll work. Right? It goes in there once. Then you have 2 left over. That makes it 23. 11 goes into 23 2 times. There's 1 left, so that's 11. That'll be that. Right? So it's not always 2, 3, and 5, what you're used to. Sometimes it's higher numbers. And 121 is actually a perfect square, which is 11 times 11, right? And you kind of expected that, right? That's the only way it's going to work really, right? So cube root of 1331 is going to be the same thing as cube root of 11 cubed, right? So that cube goes with the 3, so it's just 11. That's your answer. So perfect square, perfect cube, right? Could this be a perfect cube? No, because there's no way you could have 3 perfect groups, right? There's no way to get 2 groups of 2 in this one. So this is only a perfect square, only a perfect cube. Okay. Next, we're going to expand and simplify here. So, right, when things are multiplying, distribute that first. So 3k times k is 3k squared. 3k times 1 is 3k, right? This minus is going to distribute as well. So it basically just changes the sign of everything inside. So minus k squared plus 2k minus 1. Don't forget that, okay? And we combine our like terms, so 3k squared and k squared, that's 2k squared, right? These ones here. And then 3k and 2k is 5k. And I got rid of those, and then minus 1. So that's your combined. So if you only applied the negative to the first one here, then this would have been a negative, and that gives you just k here, right? And this would have been positive 1, so it's off. Okay. There we go. GCF LCM. So for the, if you want to do the GCF first, right, you would actually want them in expanded form. So 300 is 2 times 2 times 3 times 5 times 5. 378 is 2 times 3 times 3 times 7. 4158 is 2 times 3 times 3 times 3 times 7 times 11. And then for GCF, you only take the one they share, right? So they're sharing a factor of 2, and they're all sharing a factor of 3, right? It's almost like they have to each, all three numbers have to have that factor in it to be considered. And then nothing else really works. There's a 7 here, 7 there, but no 7 here. So it wouldn't work. They have to share. So the GCF is going to be 2 times 3, which is 6. Okay. Shared factors. And then the LCM is a contest. So there I go back to this one, right? So for the 2's, right, the highest power is 2 to the 2. Okay. For the 3's, the highest power is 3 to the power of 3. For the 5, so I'm kind of going in ascending order, right? So 5, the highest power is 2. It doesn't show up anywhere else, but the highest power of 5 is 2. If it's there, it gets a seat, okay, on the table. 7, the highest power is just to the 1, and 11 is also there, okay? So when they're really big numbers, I'd probably just get you to just show me this, and I'm probably fine with that. So that's right, this would be 4 times 25, that's 100 times 77, right? That's 7,700 times 27, so that'd be a really big number. So we'll just leave it at that. Okay, I'll probably say on the question, only write down the factors, and then I know you understand how it works. Okay. It could also ask you for the actual. We would just leave it like that. That's what I'm aiming with this question. I was just aiming for that. Okay. All right. So let's continue with our new section now. So we've learned how to multiply, how to expand and simplify. We've done that. Now what, right? So section 3.3, common factors of a polynomial. And basically, you should be thinking is factoring out a greatest common factor. That's what that is all about. And to have a better understanding, right? If you had 3m times 5m plus 4, right? If you had something like that, up until now, you were like, okay, this would be 3m times 5m, that is 15m, okay? And then 3m times 4, that's just, oh sorry, this is m squared. Watch out for that, right? Because m and m equal m squared. And then 3m times 4, that'd be 12m, okay? So this would be expand, right? But what if I asked you to, what if I started with this? Pretend like we don't know this yet, right? So 15m squared plus 12m, right? What if we looked at this polynomial here and said, wait a minute, like, look at the numbers first, 15 and 12. What's the greatest number that goes into both of them? 15 and 12. Well, that's 3, right? So you say, okay, 3 goes into 12 and 15. And then you look at the variables. What's the greatest variable with the highest power that goes into both of them? And it would be m, right? So you are basically dividing out 3m from this expression, okay? So you're asking yourself, you're going to take out 3m. That's basically what you're saying. I'm going to take out 3m from this. So how many times does 3m go into 15m squared? Well, first of all, you have to go 15 divided by 3 is 5. M squared divided by m, you're just left with m. Okay. Then you move over to, I'm always watching the sign, right? They're both going to be positive, so we just say, hey, that's going to be positive. The 3 goes into 12 4 times. The m goes into m 1 time. We don't write it down, and we're just like that. That's factoring. Okay. Okay, so if you multiply out, we call that expanding in general, and you might have to simplify. If you're going from the expanded form to this form, that is in a nutshell what factoring is. Okay, you're finding a common factor for the numbers, the coefficients, and for the variables. Okay, and I think what I'm going to tell you is that when you're dividing variables, I know you know how to divide numbers, okay? But when you're dividing variables, I'll just tell you this, recall, right? If you have m to the power of 3 divided by m to the power of 2, you're basically subtracting the exponents. So it's going to be m 3 minus 2, which is just m, okay? This is on the side, right? I just want to, some students forget that from grade 9, right? Like, how did Mr. Dirksen get, when he went m squared divided by m, it was really a power of 2 minus the power of 1 that's associated with that, so that left me with just m. Okay, so keep that in mind. It'll come back later, but you need to know that. Okay, so we'll factor the following. I'm going to zoom out a little bit. I think I'm constantly on the border there. Factor the following. So we're just going to do a whole bunch of questions here. So let's say you have 3g plus 6. If I asked you to factor this, how would you do that? This is a very starter example, right? So you look at the numbers. 3 goes into both of them, correct? So you're going to take what we're saying, well, what we say is we're going to take out a 3 from this polynomial. So 3, you cannot do g because this second term here doesn't have a g. So you cannot take that out of this expression. So it's just the 3 that works. So 3g divided by 3 is just g, right? Because the 3 divides by 3, which is 1, and the g kind of tags along. And then the next one is 6. Positive 6 divided by 3 is 2. So you have 3 factored out, and it's just g plus 2 left, okay? And you can check, right? You can check by expanding. If you were to go 3 times g, you get 3g. 3 times positive 2, you get 6. That's the way you know you did it right. If you go backwards on that. Okay, B. 8d plus 12d squared. And I'm going to do that underneath, even though they're both accurate. Okay. Look at your coefficients. Yeah. I think what I'm going to ask you to do for convention reasons, I'm going to ask you to rewrite this, okay? Whenever you have the highest power at the end, I'm going to ask you to rewrite it. So let's go 12d squared plus 8d. So rewrite highest power up front. And I'm doing this because I kind of see what's going to happen later on. I know what's coming down the road, and it's going to save you a lot of grief if you just remember that. Okay? So that's just a thing you should just get used to it. And now I look at the numbers, coefficients they're called. I can fit, you look at the 2 goes into both of them, right? But you want to go as high as you can, right? So 4 works, right? 4 is the highest common factor, and they both have at least d, so you can take out a d as well. Okay, so 12 goes, right? 4 goes into 12 3 times, and if you go d squared divided by d, you're only left with d, and then both of them are positive, so you can go positive, right? 8 divided by 4 is 2, d divided by d is just 1, and that's just that. Okay, so that would be, this would be the factored form. Just taking out a 4 is not good enough. So sometimes you'll see the word factor fully, meaning you have to do as much as you can to simplify that expression that you started with. C. 5 minus 10z minus 5z squared. Okay, so you notice that we have our z squared at the end here. So we will go minus 5z squared, bringing this to the front, and don't forget the sign, negative 10z plus 5. Rewrite. Okay, let's rewrite it. And here comes another very important piece that I'm going to tell you about. When your leading coefficient, like this number in front of z squared, is negative, you want to make sure you take out a negative. Okay, very important. So we see that 5 goes into all of these numbers. And because my leading coefficient is negative, I'm going to take out a negative 5. Can I do a z? This one has a z, this one has a z, this does not have a z, so z does not work. We can only take out a negative 5. and I will highlight this, right? Because of this, I made sure that I took out the negative. And once we factor this, I'll add that note here on the side, okay? So negative 5z, right? Negative 5 goes into negative 5 one time, and you're left with z squared only. If you want to put a 1 here, if that helps you, go for it, but it's positive. That's what you need to remember. It's now positive because these, if you divide a negative by a negative, you get a positive here. And then it's negative 10 divided by negative 5, that's positive 2, and z is left. 5 divided by negative 5 is negative 1. Okay? We always take out the negative in front of the highest power. That's what I'm going to say. That's why I want you to rewrite it. Make sure you rewrite it that the highest power is up front. If it's negative, boom, we take it out every time. Every time. Okay? Moving forward, standard practice, we take out the negative. Okay? We will check once. Check by expanding. I'm not going to do that for every question, but sometimes it's helpful to know, right? So I'm going to go negative 5 times 5z squared. Sorry, negative 5 times z squared is negative 5z squared. Negative 5 times positive 2z is negative 10z. Negative 5 times negative 1 is positive 5. Right? I'm back to the original here. D negative 12x cubed y, two variables, minus 20x y squared minus, so if you're at home, you gotta wake up now, okay? It's gonna be a bumpy ride. You can do it, I'm just making sure you're awake, okay? I want to make sure you have this written down before I continue. What is going on, right? Make sure you have the signs correct, that you have the powers written down correctly. I'm checking as I speak here, making sure that I don't make a mistake, because that's Friday. I need to be extra careful today. All right. Okay, so looking at this, right, scan it. X to the 3, that's the highest power of x, and it's up front. Perfect. That's how I want it. I'm not going to rewrite it. I'm not going to reorder it. Some of you might say, well, wouldn't you want the x squared here? If it's multivariable, as long as the highest power 3 is up front, that's don't worry about the rest. Okay? That's all I'm going to say there. So I'm looking at it, I'm like, the order is good, but I notice that there's a negative, so I need to make sure I take care of that. So my next line is going to have a negative no matter what, right? It's going to have a negative 1. I'm going to take it out right away. I look at my numbers. What goes into all of them? What's the highest factor that goes into all of them? And it would be 4, right? So 4 works. So I'm going to take out a 4 from looking at the coefficients. I'm going to look at my x. So x cubed, x squared. So you notice that they all have an x, and you kind of have to take the lowest power of it out. That's how this works, because you can't take more than an x out of this one, right? So x will also be taken out. You look at your y variables, y squared, y squared. So the lowest power of y is to the 1. Okay, and now you can start writing out. You're basically dividing this out from the original polynomial. So negative 12 divided by negative 4 is positive 3. X cubed divided by x is, you're just left with x squared, because remember it's 3 minus 1. Okay, you're left with 2. Y minus y, like it's y divided by y, it's 1 minus 1, that's just 1. So nothing there. Next, negative 20 divided by negative 4 is positive 5. X divided by x is just 1. Y squared divided by y, you're left with y. Okay. Next, negative 16 divided by negative 4, that's positive 4. X squared divided by x, you're left with x. Y squared divided by y is just y. Okay. And that's it. Does that make sense? Maybe not quite yet. Maybe you're still a little unsure. But I think, right, you should be able to follow it, especially, right, when it's y divided by y, that's 1. It's not y, it's not, right, it's just 1. We don't include that here, okay? It's irrelevant. It makes it too messy, right? Okay, E. E is, I'm picking, I have a buffet of examples here, so I'm going to see if this one is good. Note to myself, don't use s as a variable, right? I learned that. Or my writing has to improve. Okay, give that one a try. I want you to try that one. And I think I'm going to give you one more. See if you can do that. Pause right here. Okay, so I'm looking, highest power up front. I notice that it's a negative. So guess what? No matter what, even if I can't do anything else, I'll take out a negative 1. Guaranteed. So if I tell you factor and you're like, I can't do anything, yeah, there's a negative, right? You can take that out. And I look at the numbers. 5 works for all of them, right? That's the highest. Right? And then I'm looking at C. There's a C, and a C. The lowest power I take out. D, D, D. The lowest power of D is 1, right? So now I can start dividing out. You're basically dividing out, right? Negative 20 divided by negative 5 is positive 4. C to the 4 divided by C is C cubed. D divided by D is just 1. Moving on. Negative 30 divided by negative 5 is 6. Positive. C cubed divided by C is C squared. D squared divided by D is D. Moving on. Negative divided by negative would give me a positive. 25 divided by 5 is 5. C and D, right? C divided by C is 1. D divided by D is 1. So that's it. Okay, that's what you get. Yeah. This one, it's supposed to be cubed. Yeah. Oh, it looks like a 2? Okay. Thanks for letting me know. It's supposed to be a 3. Yeah. Very important. And the powers are being subtracted, right? So I think, yeah, I think I need to switch it up a little bit with the powers. So that, for example, you had a c to the 4 and a c squared out here, right? That's 4 minus 2 c squared. So we'll work on that. Okay, next, 4ax plus 8ay negative 6az. So there seems to be no highest power here. They're all kind of at the same level. No need to rewrite or anything like that when you have something like this. If you did, not a big deal. But it's just crucial when you have high powers that you bring the negative up front. So I'm looking at the numbers. 2 works for all of them. I'm looking at the variables. There's an A, and an A, so I can definitely take that out. X here, Y there, Z there. So there, X only shows up here, can't use it. Y only shows up here, can't use it. Z only shows up here, cannot use it. It has to show up everywhere. So that means that 4 divided by 2 is 2. A divided by A is just 1. And what happens to X? Well, there's nothing here to divide it, so it stays. Okay? So this one is a little weird that way. All positive, so 8 divided by 2 is 4. A divided by A is just 1. What happens to the Y? It just tags along, because there's nothing to divide it, right? And then negative 6 divided by 2 would be negative 3. A goes into A 1 time, Z is left over. So there you go. That's what you're left with there. Oh, okay. All right. Next page. For me at least. Okay. Which one here? We were at F, G. So how about this one? Negative 6x cubed minus 3x to the 5 plus 3x squared. Give that a try. I think S is fine on this one here. What do you get there? Try that. Okay. Here, yeah, this is probably where some of you probably rewrote, right? And regardless, you still take out a negative, right? Whether this is your front or you bring this one up front, or if you bring this one up front because it had the t to the 4, and I'm assuming you did that because I told you to do that, right? Let's do it. Bring that up. You told me to do that. And then I'll bring, so then you have to kind of guess, right, which one. The rest doesn't really matter. So I'm bringing this here and this, I'm bringing that to the back. So the order on something like this would not be crucial. I take out a 5. I look at R, the lowest power is to the 1. I look at S, the lowest power is S to the 1. I look at T, the lowest power is T to the 1. I'm opening my bracket. 30 divided by 5 is 6. R cubed divided by R is R squared. S to the 2 divided by S is just S. T to the 4 divided by T is T cubed. And then it's 15, negative 15 divided by 5 is negative 3. R, S squared, and T divided by T is just 1. No need to put that down. Negative 5 divided by 5 is negative 1. R divided by R is 1. S divided by S is 1. T squared divided by T is just T. And that is your factored expression right there. Don't write this down just yet. Okay, just focus on this one. I thought you should recognize this one. Surface area of a cone is that pi r squared plus pi r s. You can take out, pi is basically a number. R, the lowest part is R. There's no s in both of them, so you can't take that out. Pi divided by pi is 1. R squared divided by R is R. Plus pi divided by pi is 1. R divided by R is 1. And you're just left with S. There it is. You know what? Can you just, let's make one change. I hope you haven't completely written this down yet, but I can then address the homework with this. So the last one is a 3 and a 2, okay? Okay. So if you scan, right, if you scan them all, you have like terms, right? The first and the last are exactly the same. They're m to the power 3n squared. So you got to combine them, right? So we're going to go underline that and just say like terms. So that's probably the first order of business. So you have 30 m cubed n squared plus 18 m squared n cubed minus 12 mn squared. Okay, so you've kind of combined these two into just the 30 here. And now you can factor out. Okay. So 6 goes into all of them. M, lowest power is 1. N squared is going to work, right? The lowest power of n is n squared, or to the power of 2. 30 divided by 6 is 5. M cubed divided by m is m squared. N squared divided by n squared is just 1. Moving on. 18 divided by 6 is 3. M squared divided by m is just m. N cubed divided by n squared is n. Slow down. Negative 12 divided by 6 is negative 2. M divided by m is just 1. N squared divided by n squared is just 1. So that's it. Okay. If you do this and you end up with all three of these having an m left, right? You did something wrong, right? So, like they shouldn't have any common factors anymore because you've taken them out, right? So if you notice that, watch out. Okay, I'm gonna give you, let's write down the homework first. It's right there, and I'm gonna show you this, and additionally, I want you to do a puzzle that's gonna help us next week for what we're doing next week. Okay. It's very, very good practice, that puzzle, okay? So that's the best way to warm you up to what we're doing next. So don't think it's just a game. It's actually what's going to happen over and over again, okay? So it's not a whole lot of questions, but, you know, and if you need to go over the notes, cover up the answer, can I do this by myself? Cover up the answer, can I do this by myself, right? And then check. It's like, yeah, okay, I'm getting it, right? I'm not missing a negative. I'm not doing this. Right? Okay, I'm going to cover up the homework for a bit. So this is the puzzle that I'm talking about. It was in that package that I gave you that has like the textbook, the first couple of pages of the textbook. This is it. So what you want to do in each one of them, you want to find two numbers, right, that are multiplied. When multiplied, you get the top number, and when added, you get the bottom number. You're like, what? What's going on? So I'll show you a couple, okay? Yeah, if you want to have this out, go for it. I'll give you I'll post the answers later today. So if you want to check, it's actually fairly simple to check, right? Yeah. So this is what we're doing next week, okay? And I find that if you're warmed up to this idea, it's a lot easier to explain the rest. So you can think of negatives as long as they're two integers. Integers are right whole numbers. It could be positive, negative. So if you're thinking of 9, right? What makes up 9? Well, you can think of 1 times 9, 3 times 3, right? And so forth. So you want two numbers that when multiplied give you that, but when you add them up gives you this. Okay? So in this case, -3 times -3, right? Both negatives will be a +9. And if you were to add them up, you get -6. Okay, so multiplied gives you that, added gives you this. That's what you're after. So 4, for example, 2 and 2, right? Because if you multiply 2 times 2, you get that, and if you add them up, you get that. Let's try a more challenging one, right? So there's 30, so you're thinking 6 and 5, 3 and 10, right? 2 and 15, 1 times 30. Don't eliminate the obvious one. Okay. Here's what I want you to, the pattern that I want you to remember, okay, is that if this is negative, right, it's the result of a multiplication, right? One of them has to be negative, like they will have opposite signs. So if you want to do that, it's like, hey, if this is negative, I will make sure that one of these two numbers is negative, correct? And so let's try 6 and 5. If you were to put 6 and 5, there's no way you're going to get -13 out of that sum, out of that addition, right? But instead, 215, if you go 2 and 15, I can see that there, if you were to subtract them, there's a 13 difference there. So I would put 15 here and the +2 there, and then check. 2 times -15 is -30. But if I add them up, I get -13. So it's important which number gets the negative, right? It's not just the 2, because if you give the negative to the 2, then you get a +13 out of the addition, right? So that's what I want you to do here over and over. And sometimes you'll be stuck and you're like, it can't be done. I promise you it can, right? I've given this out enough times that I tell you, yeah, it works, right? So that is everything for today.